Hello there, friends and neighbors. I'm now going to show you how to run a multi-way ANOVA with R, Commander, and EasyR. This is in the context of Real Data Homework 12. And so I'm going to show you an example. Your questions are not going to be the same necessarily, and your numbers are definitely not going to be the same as what I do now. This is only for one particular quarter, one time in history. So I'm going to first go to the assignment. Real Data Homework 12, here it is. Click on it. And here are the instructions. Now I've already answered the first, most of the questions. I already answered the first 5 questions in the one-way ANOVA videos. So now I need to download the dataset test scores, right-click, save link as, put it someplace that you can find it again, and then import it into R, which is what I'm going to do next. So I'm answering question 6, the multi-way ANOVA question. That's what this video is about. So go down to, go down to R, which is already running, and if you've forgotten how to do that, go watch the first video, or watch any of the other videos where I've shown you how to do this, or read the written instructions on the discussion forum, or however it is you need to refresh your memory on this. Now say File, Import Data, and again it is a text file, not an Excel file. Text. It's the first option, and then I'm going to give it a cool name like Testy. And you absolutely can have more than one data set open, and in fact I do. This is my second data set that I'm opening. So go find wherever you saved the file. Here it is. Open. And now we're ready to rock. We're ready for rock and or roll. Let's see. I hypothesize that by revising tests, early scores, their grades are going to go up more than, so it looks like I hypothesize test 1 revision affects the grades, test 6 revision affects the grades, and that if we put them both together, something different happens. Specifically, if you revise both, you're going to do much better than if you revise either one alone. Okay, so I'm going to test each of those. Ultimately, it's 3 hypotheses that you get nested into a two-way ANOVA. The main effect of did I revise test 1, the main effect of did I revise test 6, and the interaction effect. All 3 of those are included. So I'm going to go to my R, statistical analysis, continuous variables, numerical summaries. I'm sorry, not numerical summaries, multi-way ANOVA. Now the response variable is estimated grade, and the factors are test 1 score. Here you have to hold down on Control to choose 2 variables, which is why if you're using, as of this video, if you're using the App Store version of VMware to log into the Centralia campus, it will not work if you're using Windows 10. The Windows 10 app version does not capture the control. So you have to use the desktop version, or if you're using a different operating system, that's not a problem. So test 1 and test 6 include the interaction term, and click OK. It gives me this awesome, very clear graph that I'm going to look at after I've looked at the ANOVA. So first let's go look at the ANOVA. So factor 1, is there an effect of revising test 1? Here's my F value, it's 2.2791. Copy that. Here's the F, 2.2791. The P value is 0.13. What does that mean? It's not statistically significant. The p-value is larger than alpha, and so revising test 1 has no effect on estimated grade. By itself, it doesn't seem to be doing anything. Now let's look for test 6. That might be because everybody revises test 1. Looking at test 6, I'm going to copy my F value, 28.7. Copy. Paste it. Copy the p-value, which is very small. This one is significant. Okay. I guess I'll do that. So that is way smaller than alpha. That is statistically significant. So revising test 6 does have an effect on grade. Then lastly, is there an interaction effect? Does something special happen when you revise both, or if you revise neither, or some other combination that requires both of them to explain for it. So let's go look at that. Here's the interaction effect line. Here's our F value, 6.428. Copy. I'll just type it. 6.4280. And the p-value is 0.01434. Okay. Now, that is smaller than alpha. I reject HO and conclude that there is an effect. So yes, the test 1 revision effect depends on whether or not you also revise test 6. To understand this, I can look at the graph. Here's the graph that it gave me. And I can see that this group here, who did not, the dark bars are the people who did not revise test 1. The left 2 bars are people who did not revise test 6. So these people revised neither test. And their score is much lower than anybody else's score. Also, these two are not particularly different. So if you revised test 6, it doesn't matter as much whether you revised test 1. And then in between are people who revised only test 1 but not test 6. But the main difference really is here. People who don't revise their tests don't do as well in the class. That's all there is to it. Okay, and I click Submit, and that's it. In the next video I'll show you how to do a repeated measures ANOVA.